Hi, my name is Juho Kim, and I'm part of the Brown Institute for Media Innovation, where we work on research projects that try to combine technology and media in a meaningful way. So in thinking about today's theme of augmenting personal intelligence, I started by reflecting on my own intellectual activities. So as an academic, I occasionally, hopefully more frequently, publish academic papers. I give talks like this to share my ideas and vision with different people that are often captured in slide decks, images, and videos. And also I write random stuff on my notes on pieces of paper and using a pen. So this is really interesting, I think, because in thinking about the way my ideas and thoughts are captured, presented, and communicated, I think it's the media, different forms of media that do this sort of job. And over the years, I started to realize that the amount of this multimedia contents has been dramatically increasing, partly due to the technology that we have in capturing these, right? We have really good editors and word processors these days. Cameras are really good at capturing the visuals and the audio signals that come from my interaction with the world. And of course, one of the greatest inventions of humankind, which is the pen and a piece of paper to capture my thoughts. But the question is, I think, we have lots of these, contents that are captured, but do they necessarily lead to improved personal intelligence? And I would say the answer is, unfortunately, not quite. So here's a little framework that I came up with in thinking about how we, collect and process and take action out of this input that we have. So that's all the input that we have, tons of resources out there. When it comes to processing, using this information, these are the things I do. I use computers to process them, use my own thinking. I search, browse, and visualize to get a better understanding of what I have collected over the years. But of course, the ultimate output that I'm expecting is to go beyond. I want to tell an interesting story out of this. I want to take action. I want to remember things better. I want to be more creative. I want to be more intelligent. So of course, with technology, there are much, much better ways to collect lots of resources easily. But do we really have the tools for processing and turning into action and intelligence? So that's where our research comes in. We're interested in thinking about building better tools that help us really browse and search through these multimedia resources and further augment our intelligence using these resources. So one of the frustrations or limitations of the state of the world at the moment is that the way we interact with these multimedia archives is more or less often by the type of media that it's in. Right? So if you're interested in watching a video, you go to a video website. If you're interested in finding an image, you go to an image gallery. If you want to look at paper documents, you go to a library with the special collection with these boxes. So they're not really meaningfully combined in a way that captures the overarching idea and thoughts and keywords. Also, if you want to track how an idea has progressed over time, it's also a really challenging task because it wouldn't suffice if you want to just look at the surface level keywords that appear. Often ideas change in their form, their way of description, even the physical look of it changes over time. And tracking these non-trivial, non-obvious changes over time is a definite challenge. So as a computer scientist and human-computer interaction researcher, our research group is really interested in sort of organizing these multimedia contents by these overarching ideas and keywords rather than surface-level features. And also we're interested in combining multimedia types that are diverse and heterogeneous and combining them into a unified and interactive archive. As a case study, we started by looking into the Engelbart archive. So we've been working with the Engelbart Institute, which is headed by Christina Engelbart, one of the daughters of Douglas Engelbart. So Doug Engelbart, probably all of you know, and now is an interactive computing pioneer who's known for the invention of the computer mouse, but his really lifetime vision was to augment human intellect. And this archive is very interesting in that a lot of these resources are captured in various forms of media. There are hundreds of video clips, thousands of images, hundreds of articles, patent documents, and books, and interview scripts, and so on, as well as physical artifacts and software demos and things like that. But of course, the challenge is, how do we combine all these in a meaningful way so that we can tell an interesting story out of this by breaking the wall between different media types? So I'm going to talk about two of the projects that we have been working in our group to address this challenge. So first one is called video digests. It's a format for browsing and skimming videos that tries to combine video and text in a very interesting way. So the idea was inspired by one of our colleagues, Brett Victor. When he gave a talk a few years ago at the MIT Media Lab, he actually turned his video into something like this. So everything is a single video. What you see is a single video where you can see that he organized his own video into different chapters. Right? So this is all single video, but then it makes it more browsable and skimmable because they're organized into chapters, and each chapter is further segmented into different sections. And of course, you can mouse over on different sections of that video.
But if I spread these out a little bit,
yeah, so you can play these segments to really get to the point in the video that you want to get. But of course, one of the challenges is that Brett is a great engineer and designer, so he could put this together relatively easily. But can anyone create this form of video representation that tries to really combine the benefits of text, which is very easy to browse and skim, but are relatively less expressive, and videos that are really expressive and visual in nature, but are really hard to search and navigate. So that's why we built Video Digests, which is a tool for making it easier for anyone to create these video digests. The way it works is that we take this input video, we segment and summarize a video clip, and then we turn that into a video digest. Of course, the key idea is that a lot of information that's going on inside a video is text-based, or we can learn a lot by looking at the speech. So the approach we took is to turn a video and transcribe the video and time align each sentence, each word into what is spoken visually in the video. And then we have two different ways of segmenting and summarizing the content. We tried to use both the automatic methods as well as the manual authoring interface. And at the end, what you get is this. So this is the view of the authoring interface where we can manually generate these video digests. So the way it works is, on the left, what you see is the editor where you can add chapters and sections. On the right, what you see is the view of the transcript. That can either be automatically transcribed using our ASR technique, which also does the alignment, but you can also use a professional service like rev.com, which uses professionals and humans to do this job. So what happens is that it allows for fine-grained browsing inside a video. So what I mean by that is,
but when you get that opportunity, you get a little nervous. I thought these students coming to us actually have the highest grade you can get in Swedish college system. So I thought maybe they know everything I'm going to teach them about.
Right, so you can really browse at the word level because of the alignment. And then you can easily create a chapter like that. I don't know if it was easy to see, but you can put a marker in any of the regions in the transcript. So it's almost like editing a text document, but you're actually impacting the video representation. So that's what we're really trying to get at. Text is really easy to browse and edit. Video is not. So why not make it almost like editing a text when you are actually working with the video? Similarly, you can add sections using keyboard shortcuts as well as buttons. In this case, we're using the keyboard shortcut, and you can keep adding these sections by just locating your marker at the beginning of the sentence in the transcript. Then, of course, you can edit the description of each of these segments that accurately summarizes what's going on in that segment. So this is the authoring aspect, right? So once you author this sort of video digest, you can publish this. So once you publish, what you get is a nice representation like this, very, very similar to what Brett has created by himself.
There. So this is where I realized that there was really a need to...
Right, so you can play different segments this way. So it provides a really interactive way for people to browse through videos. So that was the manual authoring aspect. And we've also been exploring ways to make this more automatic. So we've been applying automated text segmentation algorithm to determine right candidates for chapters. And then what we did was to recruit crowd workers online using Amazon's Mechanical Turk, which is a marketplace for these micro tasks. So you put this sort of summarization task online, give people a few cents or dollars, and then they will do the work. And we do this for multiple crowd workers and combine this. Of course, there are good text summarization methods out there that are fully automatic, but we chose not to go this route because the crowd results were much, much better. So in our case study of Doug Engelbart, I'm going to now show a live demo of one of the video digests that we've created using one of Engelbart's videos. So this video is a 6-minute long video that talks about his lifelong vision of collective IQ. So if you look at some of these chapters, it starts by how he was inspired by some of the early ideas, and then the mother of all demos, that's what he's really famous for, the debut of the computer mouse and all these really exciting techniques. And then how he started to broaden the scope of the techniques by combining them into a system like NLS. And later, he talks about his sort of vision of collective intelligence. And all of this is a 6-minute video, and you see that we organize this into 4 different chapters. So for instance, if you want to look at his inspiration, I don't know if it's easy to see from the back, but basically he was inspired by Vannevar Bush's As We May Think, and I want to look at what it means.
He had read Vannevar Bush's famous article, As We May Think. Its ideas would help flesh out the vision that became his life's work.
Right, then I want to move on and maybe look at, oh, this looks interesting. It says invested in online collaboration, document sharing. So he did that in the 60s, so I want to look at...
He showed online collaboration, including document sharing, messaging, and video conferencing.
I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. You can see my work, you can point at it, and I can see your face, and we can talk.
Great. So that was Video Digest in action. Now I want to move on to the second project that we're working on. So this one's more work in progress. We don't really have a finalized interface or product yet, but I wanted to really share the idea. So in this project, what we're interested in is how can we track how ideas progress over time? So I want to give an example by telling my version of the story of the computer mouse by browsing through the archive myself. So in 1962, he publishes this vision paper called Augmenting Human Intellect, where he talks about how a light pen, which is an input device that was used, that was popular in the 60s before the age of the mouse. And what it does is basically the same functionality as the computer mouse in that a light pen can be pointed by the human at any symbol or line on the display, and the computer can automatically determine what the pen is pointing at. So this is really the beginning of how he envisions something like the computer mouse or the light pen, the input device, can be used in a personal computing environment. And in 1964, he had this great idea while sitting at one of the conferences to basically design this computer mouse. And they started prototyping this pointing device that rolls on a desk. They didn't have the name computer mouse back then. But of course, it's related to the computer mouse, because that's how it all began. And in 1967, he actually publishes an academic paper that tries to compare human task performance of the computer mouse against some of the competing devices, like the light pen, the joystick. What you see in the middle is a knee control device. And this is the chart from his paper that the computer mouse actually shows much lower, significantly lower error rate as compared to these other devices. So this really adds evidence that the computer mouse performs much better than these other devices. And of course, the mother of all demos where the public debut of the computer mouse was done.
Okay, to talk about control devices, we'll use this overhead camera shot where you can see the devices that I'm using. I use 3, and they're not all standard. We have a pointing device called our mouse, a standard keyboard, and a special key set we have here. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up that'll show you from another point of view more about how that mouse works. Come in, Menlo Park. Okay, there's Don Andrews' hand in Menlo Park. And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way and we never did change it.
Right, so we know how the name came about. It's not very clear, but that was the public debut for the first time. In 1970, a grant, the patent was granted, and the name mouse doesn't really appear. It's named XY position indicator for a display system, but we know it's the mouse. So we need to be able to find that sort of association connection, and you see these drawings there. In 1974, the mouse has become part of the bigger system. It has been his vision all along, but he now formally sort of publishes his idea, and the mouse is part of the bigger system called the line processor and NLS. In the 1990s, he started to broaden out and started to talk a lot about his vision of improving collective IQ and how these pieces of technology like the computer mouse can be really the building block for all of this. And in his 2009 interview, he says, finding ways to augment our intellect is both a necessary and desirable goal. The mouse was just a tiny piece of a much larger project. So we know how he sees the computer mouse as. And this is his obituary, which says, one of those inventions was given a warm-hearted name, evoking a small furry creature given to scurrying across flat surfaces, the computer mouse. So I've covered 9 different instances of how the computer mouse sort of started, came about, introduced, has progressed over time. And what we're working on at the moment is to find these connections automatically and also with human assistance. Specifically, we're interested in identifying different patterns of idea progression, right? As you've seen, some of these ideas expand with more detail when he publishes patents and academic papers. They, of course, diverge and converge, become part of a bigger system, formalizes into different terms, changes how it's referred to. So using standard techniques, it's really hard to track these things because the connections are non-obvious. But using natural language processing, computer vision, some of this can be done automatically. We're analyzing a lot of these documents, create a higher level representation of these to find connections between them. We're also using crowdsourcing. We want to invite people on the web who are interested in browsing through this archive to come in and contribute their own trajectories, their own interpretations, their own stories, just like the one that I've been telling you guys, so that we can have a better understanding and sort of the crowdsourced database of these trajectories. So far, I told you about our approach to really enrich these personal narratives that are captured by multimedia. And we do so by building tools that try to organize multimedia in a non-obvious manner that tries to capture these high-level ideas and vision by trying to combine these different multimedia into a coherent and interactive archive. And working with this archive has been really interesting because we are building these tools to help people access Engelbart's vision of augmenting human intellect. But also, I think these tools themselves are really a way to enhance collective intelligence.